Guys, let us do the next theory, which was given, in the progression of the achievement of the modern periodic table. So the next theory was given by two scientists. The first scientist, whose name is Mendeleev, was a Russian scientist who had to face a lot of hardships in order to get ahead in life, and he became a professor of chemistry in St. Petersburg College of uh, of sciences, and he had given his theory very boldly, and his theory was more accepted among these two scientists. The second scientist being Lothar Meyer. In the case of Lothar Meyer, he was probably the first scientist to give the short form of the periodic table, as this periodic table which is given by Mendeleev is called as. So this short form of the periodic table was a prerequisite for the formation of the long form of the periodic table, because a lot of the deficiencies of the short form of the periodic table were overcome when the long form of the periodic table was done. However, in both these situations, by both the scientists, that is by Mendeleev as well as by Lothar Meyer, the elements were again arranged in terms of the increasing values of atomic weights, as was done in the case of Doberer, as well as was done in the case of Newland. So, in the case of Mendeleev also and Lothar Meyer, both of them had arranged all the elements in the periodic table in terms of their increasing atomic weights. So there were some of the significant achievements by both the scientists. So it is known that Lothar Meyer was the first scientist who arranged all these elements in the increasing order of atomic weights and who formed the short form of the periodic table. However, uh, Lothar Meyer, who was a German scientist, had given his theory, had published his theory a little later than that by Mendeleev, and that is the reason why, officially speaking, this periodic table, short form of the periodic table, before the modern periodic table, which is also called as a long form of the periodic table. So before the long form of the periodic table, this short form of the periodic table, which was published, which was formed, the credit for it is given to Mendeleev. However, let us also not forget the achievements of Lothar Meyer, because he was the first scientist to perform extensive experiments in terms of the plotting of the graphs for the atomic volume, as well as that of the physical constants like melting point and boiling point of all these different elements with the increasing order of atomic weights, and he tried to form a correlation between the physical constants and the atomic volume of all these elements, and he was very successful in that, because he found some amount of periodicity, not perfect periodicity, but yes, there was some correlation between the increasing atomic weights of these elements and the atomic volumes, if in case they were plotted for all these elements, as well as for melting points for all these elements, as well as boiling points. So he got some amount of periodicity, which was his achievement. His one of his failures was that he became overconfident and he required a lot of time to perform these experiments, because all these elements had to be purified before carrying out their melting point, boiling point, and for calculation of their atomic volume. So he took a lot of time for doing these experiments. So the credit for all of that goes to Lothar Meyer. Unfortunately, because of that, he could not publish his theory on time before Mendeleev. Mendeleev was a brilliant scientist, as I would be explaining to you what exactly he had proposed, and many of the features that Mendeleev had proposed in his short form of the periodic table were genius, and which was not thought by any scientist at that time, including Lothar Meyer. So the point about Mendeleev's short form of the periodic table will be that Mendeleev gave utmost importance. For him, the priority in when forming the short form of the periodic table was to ensure that all the elements having similar physical and chemical properties should be present together. They should be clubbed together at one part. So Mendeleev was the first scientist who had arranged all these elements in terms of different periods. He had named, he had in his periodic table, the construction of his periodic table was such that he arranged the elements in such horizontal rows. Now, in these horizontal rows, each horizontal row was called as periods. So, in his period table, you would see lot of different periods which have been formed. Now, also he formed different groups. As you can see, there are different groups, and in his periodic table, we had his group which is starting from 0 for the noble gases here, and then he started with group number 1 for these elements. This is group number 2, 3, 4, 5, 6 and 7. So all these elements in that is halogens which were present, which were discovered at this time, were arranged in the last group, which, as you can see, this structure, the basic structure of Mendeleev's periodic table very much resembles the structure of the modern periodic table that we have seen. That is the reason why he has been credited with a lot of appreciation for the formation of the short form of periodic table, which was an encouragement which set of minds like Moseley, who had given the modern form of the periodic table. So this periodic table was an inspiration for Moseley. Without this short form of the periodic table, it is very doubtful whether Moseley could come out with the modern periodic table. So Mendeleev was the first scientist who had given the idea of formation of different horizontal rows and vertical columns while classification of elements. So what he had done was he classified, he ensured that all the elements which were present in one particular group had similar physical and chemical properties. So again, those elements which were present here in the second group had similar physical and chemical properties. So all these elements which were present in each group had to have similar chemical and physical properties. Again, in the case of Mendeleev also, as I have already told you, he had arranged all the elements in terms of increasing atomic weights. Now you would ask me, sir, what is then the difference between Mendeleev's periodic table and the Newland's law of octave when he had given all these elements? The difference, my dear friends, is that Newland had restricted himself to atomic weight 40, that is that of calcium. However, by the time Mendeleev had given his periodic table, elements were being discovered very quickly. Every few months, some new element was being discovered, and that was a very interesting period of discovery of different elements. And once an element was discovered, it had to be put into the classification method to ensure that it fits somewhere in the classification. So therefore, here in this short form of the periodic table, Mendeleev had used many more number of elements as compared to in the case of Newland. In the case of Newland, the number of elements was restricted till calcium. In the case of Mendeleev, the number of elements was much more number of elements had to be classified. So that was a very big difference between these two scientists' theory. Next thing is that in the case of Mendeleev, as I have told you, and because that is a priority, I am telling you again, he gave utmost importance that the elements present in one particular group should have the same, very similar physical and chemical properties. For that, he was ready to compromise on other things. So the things that he had compromised was, there were some elements which had lesser value of atomic weights. However, those were placed in the periodic table after elements which were having greater value of atomic weights. So he broke his own law of arranging of the elements in terms of the increasing atomic weights. So what he thought at his time, that there might be some problem in the calculation of exact atomic weights. So he thought that the atomic weights of some of the elements were not exactly found out, and probably later on with time, when the atomic weights will be formed, he thought that after the correction in terms of atomic weights were done, his short form of the periodic table will prove to be a further success. So he was hedging on the fact that the atomic weights of some of the elements were incorrect, especially those elements who were not fitting in his periodic table even after his repeated attempts and after him spending days and nights thinking about how to accommodate those elements. So one of the examples in this situation wherein the element having lesser atomic weight had to be put after element having greater atomic weight was in the case of iodine, which had atomic weight which was lesser than that of tellurium. Even after that, it was kept after tellurium in group 7, so as to ensure that iodine is kept in this group of halogens, that is group 7 in the short form of the periodic table. As I've already told you, this will be group 7. So in group 7 he had considered fluorine, then chlorine, then bromine and iodine, so that to ensure that all the halogens are kept together. So this was one of the drawbacks of Mendeleev's periodic table. However, the credit which goes to Mendeleev is that in the case of his short form of the periodic table, he had not just considered the specific element and their atomic weight, he had considered their empirical formulas of the compounds which were being formed, as well as the chemical properties of the compounds which each element was forming, which gave him a better perspective in the classification of those elements specifically at specific locations in his periodic table. So that was one of his very big achievements. And the next was that he had, as I've already told you, he had emphasized a lot on ensuring that all the elements having similar chemical properties were put together. Now the next problem in Mendeleev's periodic table, which can be called as the drawback of Mendeleev's periodic table after we had seen the situation of iodine, was a case wherein there were some gaps in the periodic table which were kept. Like in the case of his short form of the periodic table, there was a gap which was kept below aluminum and below silicon. So there was a gap kept here in his short form of the periodic table, and the gap he had left for those elements which were yet to be discovered, and he named those elements as Eka aluminum and Eka silicon, which basically means that those elements which will be present below aluminum and below silicon in the periodic table. And he even predicted those properties or physical and chemical properties of those elements which had yet to be discovered at his time. So that was an achievement. So that was an achievement, as well as probably it was a drawback as well, because those elements were not yet discovered and he had left voids in his periodic table, which which according to modern periodic table standards is not correct. So because of the elements which were yet to be discovered, which he named as Eka aluminum and Eka silicon, those elements after discovery, they were given the name of germanium and gallium. So the element which was present after aluminum, below aluminum here, was named gallium, and that element which was present below silicon in the periodic table, it was named as germanium. After discovery of those elements, they were given this name. However, the credit which goes to Mendeleev was that the chemical and physical properties of those elements after discovery, even though the name given was different obviously, but the physical and chemical properties were very much similar to that which was predicted by Mendeleev even before those elements were discovered. So that was one of the credits which can be given to Mendeleev for his short form of the periodic table. But because he left those gaps in his periodic table, that was considered also as one of the drawbacks in his short form of the periodic table. He had, as I have told you, explained the physical and chemical properties in detail, and the detailed physical and chemical properties of those undiscovered elements were found to be true. So with this, my dear friends, we will be wrapping up with the short form of the periodic table, which we know was given by Mendeleev as well as by Lothar Meyer. Both these scientists were very important for the discovery of the short form of the periodic table.